So am I audible to all of you? Yeah, am I audible to all of you? Am I audible to all of you? So in the last classes, we just discussed regarding uh, well foundation and all, right? So we'll be moving to the last unit today. So that is what it is called. It is basically earthquake engineering or earthquake. Now all of you has done, you know, the earthquake analysis for your final year project, as far as I know. So can anyone unmute and say me what is an earthquake first of all, and also tell me about the codes that are that you people are using for earthquake analysis and all. Tell me. Can someone unmute and speak up the codes that you use for earthquake engineering? Huh? First of all, you tell me the definition. What is an earthquake? Then after that, you just tell me what are the codes and all that you use for you know earthquake resistant design of structures. Can anyone unmute and speak up? What is an earthquake? You have to unmute and speak up. What is an earthquake? I can't wait for so long. Please unmute and speak up. What is an earthquake and what are different types of waves and all? So and what are different codes that you use? So you have to unmute and speak. Yeah, please tell me what is an earthquake. You don't know this, or you are not interested. No one is interested in the class. This is very bad. No one is interested in the class. I'm asking questions and no one is responding. This is very bad.
Today our lecture is about the earthquake engineering terminologies. So in this lecture I will define and explain some of the terms used in the earthquake engineering. These are the fault, focus are the hypocenter, epicenter, the focal depth, and the epicentral distance. So I will explain one by one with the help of this diagram. So first of all, to define the fault. A fault can be defined as a surface inside the earth, a surface inside the earth across which two blocks can move relative to each other. So it means it is the surface where the two blocks of the earth can move across one each other, right? Let's consider this the one rock and this is the another rock. These are my two rocks consider. So these rocks allow to move against one another. So this surface is known as the fault. So let's suppose this is the earth diagram. This is the earth surface. You can see here above is the earth surface. Like this is the earth surface, while below here is the inside the earth. So this is the fault. You can see the fault line where the blocks can move against each other. The two rocks can move against one each other, and due to the movement of these two rocks, what happens? The earthquake happens. So that's why this is known as the fault line. So fault can be defined as a surface across which two earth blocks can move relative to each other, and due to this movement, the earthquake happens. So this was the fault. Now the second one is the focus or the hypocenter. These are the synonym of one another, focus or hypocenter. So it can be defined as the point on the fault where the slip starts. So it is the point on the fault, like this is the fault line, for example, this is the fault. You can see here, this is the fault. So the point on the fault where your slip starts, where your movement of slip starts, so this point is known as the focus or the hypocenter. The next one is the epicenter. Epicenter can be defined as the point on the earth's surface directly above the focus. Epicenter, you can see here epicenter. This is the point which is the above the focus, but directly above the focus, right? You can see here the focus here, and above the focus directly on the earth's surface, this point is known as the epicenter. So epicenter is the point on the earth's surface directly above the focus. This is the focus inside the earth. So this point directly on the earth's surface, this point is known as the epicenter, which is on the earth's surface. You can see here the epicenter is above the focus. Now the focal depth. It is very simple. The depth of the focus from the epicenter. So this distance from the focus up to the epicenter, this depth is known as the focal depth. The focus is below the inside of the earth and the epicenter is above the earth's surface directly. So this distance between these two, this is known as the focal depth. Right? Now what is the epicentral distance? Let's suppose that we are interested that there is some earthquake. We want to know about the earthquake information here. So there is some building, right? So the distance from the epicenter to our point of interest where we find the earthquake terms, right? So this distance is known as the epicentral distance. The distance from the epicenter to our point of interest where we want to find the magnitude of the earthquake, so are the other waves. So this distance from the epicenter to our point of interest is known as this distance, right? This distance is known as the epicentral distance. So these were the all points in the earthquake engineering terminologies. These were the basic points, right? In the coming videos,
Seismic activity is also one of the most important sources of information about the interior of the Earth. In this video, we're going to read about the earthquakes. So what is an earthquake? It simply means shaking of the Earth. It is caused due to release of energy, which generates waves that travel in all directions. Now the question is, why does the Earth shake? To understand that, you will have to look at this picture. This is a fault. A fault is a sharp break in the crustal rocks. Rocks near a fault tend to move in opposite directions. That creates friction, but at some point of time, their movements overcome the friction. As a result, they slide past one another. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus of an earthquake, or there is also a term given to it called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. This place is the first one to experience the waves. All natural earthquakes take place in the lithosphere. The lithosphere refers to the portion of depth up to 200 km from the surface of the Earth. An instrument called seismograph records the wave reaching the surface. The waves look something like this. The curve shows three distinct sections, each representing different types of wave patterns. We'll get back to this pattern in a moment. Earthquake waves are basically of two types, body waves and surface waves. I need you to understand the term body waves. Sounds a little larger within the body, right? So the body waves are generated due to the release of energy at the focus, that is the epicenter, and moves in all directions, traveling through the body of the Earth. You know, it travels internally within the Earth's surface and moves the interior of the Earth. That's why it is referred to as body waves, because it is traveling through the body of the Earth like a tremor. Now it is obvious that when these body waves move towards the surface, they will come in contact with the surface rocks and generate new set of waves. These are called surface waves. Now the velocity of waves changes as they travel through materials with different densities. And we know that the materials with higher density reside downwards. Therefore, the denser the material, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. That's why when the seismic waves reach towards the surface of Earth, there the materials are of lower density, and that slows down the intensity of the waves, leaving behind a fault. Now going back to the picture that I showed you. So if you look at this picture, there are two types of body waves. They are called P and S waves. So the letter P and S stands for primary and secondary. Now you can relate when I say primary, they are the first one that gets recorded on a seismograph, the instrument, and then comes the secondary wave. You can look at this illustration to understand how these wave looks. The P wave, that is the primary or pressure wave, is a pulse of energy that travels quickly through the Earth's solid materials as well as liquids. It forces the ground to move backward and forward as it gets compressed and expanded. The S wave, that is the secondary or shear wave, follows more slowly with a swaying, rolling motion that shakes the ground back and forth perpendicular to the direction of the wave. If at all the concept of P and S wave isn't clear to you, I recommend that you watch this video by Dr. Keith Miller, where he physically demonstrates P and S seismic waves. The video by him is extremely helpful. I'll link the video in the description and you can go and have a look at it. Now going back to this picture, after body wave, that is P and S waves, comes the surface waves. The surface waves are the last to report on seismograph. They look something like this. This wave spreads across the surface of the Earth. These waves are also more destructive and damaging. They cause displacement of rocks and hence the collapse of structures occurs. If you want to see more of such educational content, make sure you subscribe. By doing so, you'll get alerts when the next video comes.
Now, as per definition, an earthquake is a sudden or rapid shaking of the ground. So, the scientific study of earthquakes is basically called seismology. Okay, and earthquakes are measured using observations from seismometers. Seismic waves are recorded on instruments that are called seismographs. The time, location, and magnitude of an earthquake can be determined from the data recorded by seismograph stations. Now, if you go to the next one, so as you can see in the video, also you saw like how the wave travels. So in the bottom, you can see this is the focus of the earthquake. So the point from where the earthquake actually originates inside the ground. Now the point which is vertically above it, this point is known as what? The epicenter of the earthquake. Okay. Now in the epicenter, the shock waves are what? Very high. That means you will feel the maximum amount of what do you call it? Uh, Shaking or vibration. Then eventually towards the end, it will lessen up. Now what is the Richter magnitude scale? Now the magnitude of an earthquake is what? Measured by using Richter scale. Okay. So it was developed by 1935 by Charles F. Richter. Now earthquakes with magnitude about 2 or less are usually called micro earthquakes and are generally recorded only on local seismographs. That means below 2 they are not of any concern. Okay. Now earthquakes with magnitude about 4.5 or greater are strong enough and can be recorded in sensitive seismographs all over the world. The great earthquakes have magnitude 8 or higher. Now recently an earthquake that occurred in Guwahati. So if all those who were in Guwahati, can you say me about it? What was the magnitude of the earthquake that occurred recently, the bigger one? Can you unmute? Can anyone unmute and say what is the magnitude of the earthquake that occurred?
6.5, sir.
Yeah, good, very good. It was 6.4 actually. So that was the magnitude that occurred in Guwahati recently. It was a it was a big earthquake, I would say. Okay. Now the classification of earthquakes and all, these are all done on the IS code. We have two IS codes, 1893 and 13920. Then this is the Richter scale actually. Look, now these six are what? Moderate. Beyond six, it is what? Strong earthquake. Okay. So this is the basically Richter scale. So this is how the damage, is calculated. Okay. Till now, the largest recorded earthquake is of 8.9. It was recorded in 1960. Okay. Then the causes of earthquake. The natural causes of earthquake are these are the natural cause of earthquake. Okay. So tectonic movement, then volcanic activity, then pressure of gases in the interior, landslide avalanches, faulting and folding of rock beds are responsible for causing minor earthquake. Now, tectonic earthquake and volcanic activity are the major reasons why majority of earthquakes are caused. Okay. Now, man-made earthquakes. There are certain earthquakes or vibrations that might be man-made also. And these man-made earthquakes are generally caused due to bomb bursts or bursting of bomb explosions because there is certain shake in the ground in those cases also. Okay. Now, if you can see this, number one, the impounding of large quantities of water behind the dam. It disturbs the balance. Then you will go to the next one is sockets through rock setup by underground testing of atom bombs and hydrogen bombs. You know, the atom bombs and hydrogen bombs, those were tested underground. This may be severe to cause an earthquake. Now, the effects of earthquake. First of all, is destructive effect. These are the destructive effects of earthquake. So, from this effect, if you can see here, you know, it causes damage to buildings, then railways. Everyone knows that. Like, but if earthquake originate in seas, this is a very devastating thing because it will lead to what tsunamis. Recently, few years back, there was a tsunami in the southern part of India. Around 15 years back, I think so. Then the earthquake resulted in the formation of crack. Then earthquake caused landslides. So these are all certain effects. Not a seismic belt. Now look, the earth is divided into several major and minor plates. Right. Now if these major and minor plates, the place between the plates, I mean the zone between these areas are the mostly vulnerable to earthquake. Okay, these zones generally are very much vulnerable. They will lead to earthquake and all. Okay, we'll discuss about it. Now, if you can see, this is the earthquake zone map of India. Actually, in India, though this is a no presentation, actually, in India nowadays the zone is from two onwards. Okay, just now in the video you saw about the seismic waves and all. Video that I'm going to show you to show you the causes of earthquake in a more illustrative manner.
What just happened? What just happened? Did we just experience an earthquake? But why does this happen? And what exactly is an earthquake? Earthquakes are caused by the release of energy that generate waves which travel in all directions, causing the shaking of Earth's surface. What exactly is this energy? What waves? What's shaking of Earth's surface? This is so complicated. Well, calm down. Let me explain everything in a simple and detailed manner. Earth is not just one piece. It is made up of jigsaw puzzles of around 19 to 20 pieces, which are called as tectonic plates. These plates are placed on a hot, partially molten layer of Earth's mantle. This is the reason why these pieces are continuously moving. They are moving as you are watching this video. These plates move around 1 to 10 centimeter each year. But don't worry, not all these movements can be felt by us. Sometimes these movements are extremely strong and can be felt like a lot of vibrations under your feet. Or it can also destroy an entire city. That's called an earthquake. The earthquakes occurs in the lithosphere region of the earth. An earthquake generates underneath the earth and this releases the energy across. The point at which the earthquake occurs under the earth is called hypocenter, and the exact place above it at the surface of the earth is called epicenter. The most horrifying earthquake recorded till date was of magnitude 9.5 out of 10. This happened in Valdivia in southern Chile in 1960. Another one that happened in Japan in Tohoku region was of magnitude of 9.0, which happened on March 11, 2011. This earthquake caused massive and enormous damage and destruction and took nearly 16,000 people's life with him. Geologists use a device that can sense the waves created by the movement of the tectonic plates. These waves are known as seismic waves, and the device is called as seismograph. The earthquake events are scaled according to magnitude of the shock and are known as Richter scale. This magnitude relates to energy released during the earthquake. Magnitude is expressed in absolute numbers 0 to 10, where 0 is lowest, where people feel nothing, and 10 being the highest that can create severe destruction and loss of life over a large. In order to know more about earthquake, let's jump to the simulator. We can see on the screen is the inner core of the earth, and then we have outer core, mantle, and crust. The inner core, as the name suggests, is the innermost layer or the central layer of earth. It is like a solid spherical ball in nature with a radius of 1250 kilometers. The temperature of Earth's core ranges between 4500 to 5500 degrees Celsius, facing a pressure of 300 to 360 gigapascals. Next is outer core. It is of about 2200 kilometer thickness and has a temperature similar to inner core, that is of 4500 to 5500 degrees Celsius. Then we have the mantle layer, which is the semi-solid state of about 2900 kilometer thickness. This layer makes around 84% of Earth's total volume. And the last layer is the crust, which is like an apple skin when compared to other layers. Runs from 0 to 70 kilometers in thickness, which is specifically 8 kilometers under sea to 32 kilometers under continents, and this is only 1% of the Earth's total mass. Now we can see that there's a grayish-white dot. Let's click on that. We can see a small town when we see this in the street view, and then when we click on layers view, we can see Earth's layer. The grayish in color is called as crust, and the one in reddish color is called as mantle. On the left-hand corner side, we can see we have a small box that says earthquake magnitude on Richter scale with 3 buttons that shows the magnitude of the earthquake. If the intensity is between 0 to 2, it can be barely sensed. When the intensity is more than 2 and less than 4, we can feel minor vibrations and sense it a little. From 4 to 4.9, it is considered as small or a light earthquake. Range from 5 to 5.9 are considered moderate earthquakes, and from the range 6 to 6.9 are considered as strong earthquakes. In some time, we will see how much damage these magnitudes can do. And anything above 7 is considered as major earthquakes which can destroy cities and continents. These readings are recorded on a seismograph. Now, let's hit the 4 to 4.9 magnitude to see how this earthquake happens. We can see the earthquake starts from a point called a hypocenter inside the earth. During an earthquake, 2 types of waves are formed. One is called body waves and the other are called as surface waves. Let's see what are called as body waves. Body waves are the waves that move through the interior of the earth and through the body of the earth, and hence the name. When these body waves move, these waves come across the surface rocks and generate the surface waves. Let's see in detail about these body waves and surface waves. From this point, that is hypocenter, waves are released. These waves are called primary waves or P waves. Now, what are these P waves? P waves are seismic waves that shakes the ground back and forth in the same direction and the opposite direction, as the direction of the wave is moving, which is similar to the movement of these sound waves. This is how a P wave looks like. These P waves are the first to be recorded on a seismograph. Now, after a fraction of a second, when these P waves hit the rocks closer to the surface, gives rise to a new set of waves, the S waves, or called as secondary waves. These waves are towards the earth crust, and these are tremors and vibrations that we feel. S waves are the wave motion in a solid medium where the medium moves perpendicular to the direction of the wave. After the P wave, these S waves are recorded on a seismograph. Now these S waves hits the surface and starts the earthquake. The point at which the earthquake originates on the surface is called an epicenter. After the P and S waves comes the surface waves, which are the most destructive waves as they cause the movement or the displacement of the rocks, which leads to falling of structures and causing harm to life. Let's once again see the formation of P and S waves. We can see that an earthquake of this magnitude, that is between 4 to 4.9, causes the damage to nearby small houses, but the buildings are okay. Let's see what happens when the magnitude is between 5 to 5.9. Let's reset and then hit the button. Whoa, that's quite some damage. Notice this, when we move to 6 to 6 point really be extremely dim, how 9 and 9.5 might even look. Since these are quite commonly occurring magnitudes, we have studied them in this simulation. It is extremely difficult to predict an earthquake based on a seismograph, which is also known as seismometer. But even our smartphones can now detect these seismic waves, and scientists can use this data to predict earthquake and warn people. NASA can use this information in the QuakeSim software, which can use this data to generate more efficient information. Recent studies showed that before an earthquake, nearby regions record very high concentrations of radioactive pair radon and thoron. This happens because right before the earthquake, these gases are released on the surface from small cracks, and if we can detect these gases, we can predict a quake at least 7 days in advance. Well, here are some tips that can save you in case of an earthquake. Till then, keep